Hello, my name is Choi, and I'm working in the PopcornSAR. So I will give a presentation about the AUTOSAR adaptive platform with the digital twin environment for SDV. Yeah. So before my presentation, I will introduce our PopcornSAR shortly. So PopcornSAR is an adaptive tool vendor located in Korea. So we focus on AUTOSAR tools. So we have provided the AUTOSAR Australian tool, AUTOSAR. These two cover AUTOSAR platform and adaptive platform both. And we have our functional cluster full stack. This name is PAR. So current customer require R2011 version of adaptive AUTOSAR. So we are focused on the maintenance of the R2011 version now. So also we have cloud native development tool. So in this environment, it contains the AUTOSAR, all AUTOSAR tools, so like modeling tool and coding tool and code generator and functional cluster stacks and this environment contains a simulator for autonomous driving or issue test. Yeah. So what is need to realize SDV? Yeah. There are many opinions, but one of key for achieving SDV is application ecosystem. So by designing and providing service interfaces, developers in various fields can offer diverse applications with their new ideas. So many people predict that this application will be the key in the future automotive industry. So providing an application ecosystem is important for SDV, and the most important thing is that meaningful development environment must be provided to software engineers. To enable this, first, a common software platform for vehicle is necessary. So there is a good example. This is AUTOSAR. So secondly, issues that provide common automotive functions are required, especially communication topology, that the in-vehicle network topology and service providers shall be defined. This factor is also supported by AUTOSAR already. Finally, the common integrated development environment for developer is essential. So this ID, shall be provided to the software developer. This illustration shows cloud native development for SDV. This figure is very simple, but already provided by PopcornSAR now. To achieve on application ecosystem for SDV, a common development environment for engineers is necessary. So cloud native development is suitable for this purpose. This environment includes IDE for implementing AUTOSAR application, virtual issue for running develop adaptive application, and DevOps to support actions process. What type of applications provided in future will play an important role in the automotive business. And it is important to involve people with various ideas to achieve business. An accessible development environment like smartphone applications. So, however, there is a specific characteristic in vehicle application. This is safety. So, in SDV, it is essential to respond quickly to new application updates. Therefore, development environments and processes like Agile have recently been introduced applied and reviewed control. But there is an unchanged goal for using any methodology. It is to reduce development speed. In other words, development cycle shall be more faster, but verification time also shall be more faster. However, due to the nature of the vehicle, safety is very important, and safety can be minimally guaranteed only after verification is completed. So in traditional verification phase, it takes a lot of time and cost to obtain verified results. Not only as you know, we tested with software in the loop, and then testing hardware in the loop. Finally, we shared test in the real vehicle. To reduce time spent on this verification and to prepare for better situation in advance, digital twin is essential. Yeah. So through the digital twins, we can gain some benefits. First, digital twin allows for the pre-design and development of the physical environment of the vehicle, like body shape, sensor installation, and location. Second, it is easier to construct environment like actual driving conditions, such as road, traffic, weather, and pedestrian situations. So also we can build various driving scenarios in digital twin. The virtually constructed result reflects actual physical elements, and we can perform functional verification of the implemented application. So essentially, we are developing environment for SDV development with some customer by integrating digital twin with the adaptive AUTOSAR platform. The overall work process with digital twin is identical to AUTOSAR methodology. The designer who perform AUTOSAR system design and the implementer as additional application design to AUTOSAR system design, he will generate the code and manifest files based on design model. Using the API code and manifest generated based on the design model, the implementer develops code and compiles to create adaptive applications. So these adaptive applications are installed on the target hardware through the UCM, diagnostic, or direct putting. The target hardware can be a development board or developer desktop. In other words, this is a method of verification application by running the created application and communicating with the digital twin. So this page presents the integrated development environment for adaptive application developers. Application developers implemented and built adaptive application using the AUTOSAR SDK in DID. So the application can be ported to the issue and communicated with service instance implemented in digital twin for actual verification. For adaptive AUTOSAR, it is easier to check the current development status if the digital twin tool is installed on the developer's desktop. So the auditive application presents in ID or issue represented the target for implementation by software developers or vendor. And it is communicated with the digital twin to simulate and verify whether the application development has been developed well with our intention. Yeah, so this compound diagram shows the architecture between the digital twin and AUTOSAR auditive platform. This result actually carried out by PopcornSAR already. Most digital twin provide vehicle control information and sensor data, but in reality, each company provides the interface in their specific way. So in this system, we have integrated the digital twin use either a UDP to provide the vehicle sensor data like camera, LiDAR, and radar. And this digital twin to provide the vehicle control data communicated over CAN. So to communicate with digital twin tool, we use the Arcon low stream API to provide the service interface through simulation auditor application. Additionally, we implemented S2S translator auditive application that received the CAN data using a specialized CAN driver like Linux on CAN socket, and it provides the data to the service interface. So through these two auditor applications, we implemented the concept of distributing digital data from digital twin as a service. Yeah, so after development and verification is completed, the auditor application will be removed. In release page, vehicle functionalities are provided with the real service interface. So therefore, if service-oriented architecture design and implementation are done correctly, application will work without any issues. In other words, auditive application use the find service API to connect with the service provider. Yeah. So this result shows the verification of autonomous driving logic through the integration of the AUTOSAR auditive platform and digital twin. In the left side, this tool is AUTOSAR IO, and this tool represented about the model software component architecture. Below, there is a console. It shows the application running state by auditive application, and this console message is implemented in auditive application. So in the right side, this tool is Moration, digital twin tool for autonomous driving. So using this environment, developers can implement meaningful implementation result. So this is the last page of my presentation. So using digital twin, verification result almost identical to real vehicle test can be performed along with development. So this has So the advantage of allowing immediate feedback to developers. So it can improve productivity for development. Also, the combination between AUTOSAR adaptive platform and digital twin is so high. It has a high efficiency, and it is easier to integrate the adaptive platform and digital twin tools. So if the entire tool chain is provided in one development environment, it is excellent. And basic support is in this environment. So this factor enhance service-oriented architecture implementation and verification. However, there are some consideration. While it is excellent for software logic verification, there is still a gap in bringing hardware-dependent verification, such as real-time and latency, to hill level. So additionally, what service OEMs will provide is more influenced by business situation and sharing them by technical implementation difficulty. Once these considerations are solved, adopting digital twin can help reduce resources such as development time and cost. Digital twin and real vehicle shall provide defined service as a common feature. It means providing vehicle data from the digital twin at the service level rather than the signal level. Thus, in this figure, all ports or AUTOSAR ports, all AUTOSAR ports are provided port in diagram. Yes. The digital twin directly provide the service provider of common issues such as sensor and control. Therefore, application developer can develop their application using the vehicle service. In conclusion, the adaptive application developer can use the same services as actual vehicle, facilitating the development of SDV applications. Yeah, so now PopcornSAR can offer the solution and proposal to resolve these concerns and contribute to advancement of SDV technology and adoption of AUTOSAR adaptive platform. My presentation is finished. Yeah, if you have a question.
Thank you very much, Mr. Choi. Are there any questions? Yes, please. Welcome.
Thank you for the presentation. I have a question on your slide 5 or 6 where you showed the CAN socket for the S2S translation. Yeah, exactly. So what kind of socket is it? It is maybe you said it's built on top of Linux driver. So you use some kind of vSock or eNet socket to open a CAN portal to this. And since it is a virtual, I'm assuming it's a digital platform. So, and CAN is a more periodic-based communication. Do you see any tolerance, or do you take any tolerance? Because on Linux, it can become unpredictable. The periodic messages coming into the interface. So, what are your thoughts on this?
Yeah. So in this system, we developed the S2S translator application based on the HANA API and Linux specific API. So there is your API Linux Linux on CAN socket. So our customer requirements do not use MCU, only use a high performance CPU. Yeah, so we use the CAN socket in our application. But this CAN design the auditive application now in the standardized in the AUTOSAR schema. So we created the API specific in CAN socket, and so CAN communication enables in this system. But there are some issues to implement this application because first consideration is that can the project OS the project OS is not standardized in AUTOSAR. Second, we have based on we have experience about the tolerance of receiver can frame in Linux is not guaranteed about tolerance. Yeah. So in this case, can frame period is some long over in my as I remember that period usually over 15 minutes.
Yeah, that's my answer.
Okay. Thank you for presentation. I have some small questions. You explained the digital twin solution in the slide. So, in our point of view, to enable a single issue with the digital twin, there is many kind of peripherals simulated in the digital twin platform. How can you elaborate how can it possible? So, in addition to camera right now, so there is many peripherals connectivity also required for digital twin platform. It is possible to simulate that kind of connectivity also.
Yeah, so I think it is possible, to implement some instance in the desktop or developers environment, there are many issue instances in the one machine. So it must make the issue for running the instance in the same time. So in this presentation, digital twin tool provided through the cloud. So they have divided instance to cloud to each one issue to one instance. So they solve the performance issue in one desktop. Yeah. So I think in digital twin tools need more optimization of the performance.
Thank you.